So our lesson today is to subtract linear expressions, and our this is again module 6, and this is lesson 6.3 in module 6. And our learning target, I can use different methods to subtract linear expressions, right? And the vocabulary that we are going to be working on is additive inverse. And if I look at additive inverse, we've done that in the past with numbers. Basically, if I say 6, the additive inverse of 6 would be negative 6. So basically, the opposite. When I take 6 plus negative 6, what am I getting? I'm going to get 0. So basically, that is additive inverse. And we are doing the same thing with expressions now. So if I look at that term, additive inverse over there, when two expressions have a sum of 0, the expressions are additive inverses. Okay. So to find the additive inverse of an expression, we basically use the distributive property to multiply the expression by negative 1. Okay. So let's say I have this one, 4x plus 2. If I need to find the additive inverse of this, all I'm going to do is use the distributive property. Okay, that means I am multiplying the number outside with each term inside, and I am going to multiply this with negative 1. All right, and so negative 1 times 4 gives me negative 4x, and negative 1 plus 2 is going to give me plus negative 2. And so basically, what is this going to give me? If I take 4x plus 2, and this becomes negative 4x minus 2, right? So basically, what am I doing? I'm just flipping the signs in this case. So if I take these two and I add an expression with its additive inverse, okay, so negative 4x minus 2, okay, you can see that I'm going to get what? I'm going to get 0x minus 0 basically, or 0. Okay, so therefore whenever I look at additive inverse, I'm looking at any expression and I am multiplying the expression by negative 1. I'm going to simplify, and then after that I'm going to arrange the like terms in the same column. So look, the x's and the x's and the numbers and the numbers. And then when I add the additive inverse, so if I take the sum of an expression with its additive inverse, I'm going to get a 0. So the simplest thing to remember in this case is just take what numbers I have and I flip the sign, and that basically is what the additive inverse is going to be. All right. So let's try if I say 5x minus 7. Okay. If I say 5x minus 7, so what is the additive inverse of this? So basically, what am I doing? I am just taking this number, this expression, and I am going to multiply it with negative 1. And when I use the distributive property, negative 1 times 5 gives me negative 5x, and negative times negative gives me positive. So plus 7. So as you can see, look, the sign is completely opposite of this. This is 5x, this is negative 5x. This is minus 7, this is plus 7. And so when I add these two, I will get a 0. Okay, so the additive inverse of 5x minus 7 is going to be negative 5x plus 7. So just flip these signs, and that makes it your additive inverse. Okay. So let's go ahead. What if I have just, another quick example, negative 7x, and I have plus 3. What would the additive inverse be of this? What is the opposite of negative 7x? It would be positive 7x. What would be the opposite of positive 3? It would be minus 3. So look how I've switched the signs, and that's what gives me the additive inverse of an expression. Okay. So subtracting linear equations, when I subtract linear equations, it is very much like addition, but now in the sense that we are putting them in columns when we are subtracting. The only difference is just like we had done with integers, you add the opposite, keep change, flip. That's exactly what we are going to do with the expressions also. Okay. So if I have 8y minus 5, 8y minus 5, and I have minus 3y plus 4. Okay, I have 3y plus 4. So when I have something like this given to me, what I am going to do now is I am going to arrange the like terms in columns. Okay, so 8y minus 5 minus the like terms are 3y and with the 8y, so 3y plus the 4. So here is my first step. I am going to put them or arrange them in columns, okay? The next part is that I am going to add the additive inverse. So additive inverse, I'm just going to put this arrow so you can see. The first one is keep. So this is keep, change, flip. Okay, so 8y minus 5. All right, change the minus to the plus, and then flip the sign of the second expression. So what is the opposite of 3y? It is going to be negative 3y. Okay, what is the opposite of plus 4? Minus 4. Okay, so as you can see, I just flip the sign like this. Okay, and now all I'm doing is adding or subtracting, and you know, the subtraction part has been converted into addition. And then I look at, okay, are these signs the same? No, they're not. So I'm going to subtract what is 8 minus 3 because the variables are the same. So I'm combining the like terms in this case. So 8 minus 3, and I get 5y, and then I can see that both of these are, you have negative 5 and you have negative 4. So when I have same signs, all I'm doing is adding them up, and 5 and 4 give me 9, and the sign in front is a minus. Okay, and we had talked about how to do this in the earlier module where I have the same signs, so I add them and give that common sign to those numbers. And so if I'm solving this one, subtracting linear expressions, basically these are the steps that need to be followed. Okay, so let's quickly do one using algebra tiles, and then of course in putting them in these columns. All right, so I'm going to show you two different methods. We can also use algebra tiles in order to solve this. So if I have 6x plus 5, I have 6x plus 5 minus 3x minus 2. 3x minus 2. Okay, so first I'm going to model 6x plus 5 using my algebra tiles. Okay, so I have, this is my 6x plus 5. How many x's do I have? I have 6 x's. So 1, 2, 3, 4, 5, and 6 x's. 1, 2, 3, 4, 5. 6 x's are here, and I have 5 ones. So I have 5. So therefore, here 1, 2, 3, 4, and 5. Okay, to subtract 3x minus 2, we are going to add the additive inverse, which would be what? If the additive inverse of this one, I would get negative 3x, and the minus would change to plus 2 because I am just switching the signs, as you can see. Okay, so I am going to take the additive inverse. So I have negative x negative x, because I have three x's, right? Three negative x's. And I have negative x. And I have plus 2. So 1 and 2. Okay? And then I am going to go ahead and I am going to make my zero pairs of a positive and a negative like we did in the past. And here is x minus x0, x minus x0, x minus x0. So here are my three zero pairs. And then we look at what do I have left. So what I have left, I have this left, and I have this left over. So if I look at that, I have 1, 2, 3 x's, and 1, 2, 3, 4, 5, 6, 7. So 3x plus 7 is my answer. And this is if I am using my algebra tiles to solve this. Okay, this is with the use of algebra tiles. The second method is to arrange the terms in the columns. Okay, so we are going to add the additive inverse. So if I'm putting into columns, I have 6x plus 5, right? And then I am going to add, this is the additive inverse. So plus, and I have negative 3x plus 2. Okay, so I'm adding the additive inverse. And then all I'm doing is 6 minus 3, opposite signs, right? So I get 3x plus 5 plus 2 is 7. So look, doesn't matter whether I do it this way or I do it with algebra tiles, I still end up with exactly the same answer. But you can use either method to represent the subtraction. Okay, so let me show you another example. All right, so if I give you a problem, negative 3x plus 9, negative 3x plus 9 minus 8x minus 7, 8x minus 7. Okay, so the first thing I'm going to do is look at this and change the signs, because what am I doing? I am trying to find the additive inverse. Okay, what is the additive inverse of 8x? It would be negative 8x. What is the additive inverse of minus 7? It would be plus 7. So if I look at this, this is what I'm doing: keep, change, and the flip. And keep is this part. Okay, so keep the original expression, change the minus to the plus, and then flip the signs. So I am basically doing the additive inverse. And then I can arrange them in columns. And I have negative 3x plus 9 plus I have negative 8x plus 7. Okay, and now I can see same signs. So when I have same signs, I add those values. So I have negative 3's and I have negative 8's. So 3 plus 8, and I am going to get negative 11x plus I have 9 plus 7, as I can see over here. So same sign, so I'm just going to add them and I get 16. And so here is my final answer to this one. Okay. Let's do one last example of subtracting, and we are going to use again linear expressions with fractions, but the method is exactly the same. Okay, so if I give you 2/3 x, 2/3 x plus 1/2, plus 1/2, okay, minus 1/6 x minus 3/8. Okay, So we are going to follow exactly the same thing we've been talking about. That means keep, change this sign, and flip the signs. Okay, because we are going to add the additive inverse. So keep the first one, and I get 2/3 x plus 1/2. Change the minus to a plus. Okay, flip the second signs over here because I am finding the additive inverse. So therefore, opposite of 1/6 would be negative 1/6 x. Opposite of minus would be plus 3/8. Okay, and now all I'm doing is I'm going to arrange the like terms in columns. Okay, so I have 2/3 x plus 1/2 plus I have negative 1/6 x plus 3/8. The next thing I'm going to look at is if I am adding fractions with unlike denominators, my denominators need to be the same. So I'm just going to do this. Okay, so I am going to change both of them to the same common denominator for the x's and the same common denominator for the 1/2 and the 3/8. So if I look at 2/3 and I look at negative 1/6, I know that the common denominator is going to be 6 over here. Okay, and this is x and x. All right, so then we look at 3 times what? 2 gives me 6. So same thing, whatever I do to the denominator, I do the same thing to the numerator. And 2 times 2 gives me 4/6 x. The bottom one is already in the format of 1/6, negative 1/6. All right, and then we are going to do the same thing with the top, and we look at 2 and we look at 8, and I know that these are unlike denominators. So in order for me to find the least common denominator, I can see that my least common denominator is going to be 8. So I am going to put the same common denominator for both of these values, and 2 times 4 gives me this 8. So same thing, whatever I do to the denominator, I do the same thing to the numerator. And 1 times 4 is 4/8. And then this is already with the denominator of 8. So now when I add it or subtract, because this was addition, right? We can see these are opposite signs. So I am going to subtract and give the value of the bigger absolute value. Okay, so what is 4 minus 1? I get over here 3/6. Okay, I get 3/6. And since the sign in front of the bigger number is positive, this stays positive. Okay, and then I have 3/6 x plus, we are looking at these both positive, so I add them. What is 4 plus 3? I get 7/8. 7/8. And then the last step is I'm going to look at, are my fractions in the simplest form or not? So 3/6, if I find the greatest common factor, it is going to be 3. So I divide 3 and I divide 6 by 3, and I am going to get, let me write it this way. Okay, so this one I'm just going to write it here. I'm going to get 1/2 x, all right, plus 7/8. And this is going to be my final answer. All right, so no matter whether I am doing it with whole numbers or if I'm doing it with fractions, the process is exactly the same thing, where I am using the additive inverse in order to solve the linear expressions where subtraction is concerned. All right, I'll have a great day.